Hi, I'm WebP3. So today I'm going to explain to you how to calculate algebraic products and what we actually mean by them. So product, remember, product is anything that has to do with multiplication. So we are going to look at multiplying algebraic terms. So let's look at an example, or actually let's look at a couple of examples here. So very easy example would be, let's say, 6 times 3x. Now, we already know, and actually this is something that we need to disconnect from again, that this 3 and the x belongs together, because actually it is nothing else but 6 times 3 times x. So the 3 and the x don't belong together. That's the same as saying 3 times x. Now what we need to do, we can calculate what 3 times 6 is, or 6 times 3, sorry. And 6 times 3 is 18. And then we have here 18 times x. And we know that from our notation, we don't write that times here. We write 18x. And that's the answer to this question. Let's look at another example where there is more than one variable involved. So let's say we wanted to calculate 3x times 7x. So again, that's the same thing as writing 3 times x times 7 times x. And because in multiplication we can rearrange our terms that we have here. Be careful, this is only possible because we can do that within a multiplication, because we know that, for example, let's look at 2 times 3, which is 6. And that's the same as 3 times 2, because it's also 6. So within a multiplication, we can move our terms around. As soon as there is another operation like an addition involved, we can't do that anymore. But here we can, so we have 3 times 7 times x times x. So let's look at what we get here. 3 times 7 is 21 times, and we can also simplify that because we know that x times x gives us x squared. And again, we do know that we don't want that times in between our 21 and our x squared. So what we get here is 21x squared. Sorry, so now I'm getting in the way of that side note that I made here. So that's the answer to this problem. Let's look at a couple more. So what if we have, let's say, we have, let's look at a different variable just to mix it up a little bit. We have 3a squared times 4a. And now there is another important thing. I'm going to write this out. 3 times a squared is the same as a times a times 4 times a. And again, because we have here all multiplications, we can rearrange however we want within this expression. So we want that 3, the numbers together, the 3 and the 4, and we want our a's together, 3 times a times a. And now we can calculate. 3 times 4 give us 12. And we have a times a times a, which gives us a cubed. And now note here, I didn't even write that times anymore because I already know that 12 times a to the power of 3 is the same as 12a to the power of 3. Now, let's take it up a notch. Let's look at an example where we would have 2a to the power of 3 times negative 5a squared times a. Okay? And again, what we're going to do, because we know that we have, so let's write it out. 2 times a to the power of 3 is a times a times a times. Then this bracket is here because we can't have two operational signs right next to each other, because we need to separate them with a bracket. So if I wanted to get rid of that, or actually get rid of that bracket here, we'd still need that bracket, but we could write negative 5 times negative 5 times a times a, because that's our a squared here. And again, times a. And then, because we have here all times, there's not a single addition or subtraction here. Note, this is not a subtraction. This is a negative 5 here. Yeah, that's not a subtraction. That's a negative 5. So we can have here our 2 times negative 5. And then we have times a times a times a times a times a times a equals 2 times negative 5 gives us a negative 10. And we have here 1, 2, 3, 4, 5, 6a, so that's a to the power of 6. And now I'd like to point out a very important thing. Let's look at the indices that we have here. This is a 3. This is a 2. And what's that index here for the 1? That index here for the 1, that index here for the a is a 1, because it's a to the power of 1. A to the power of 1 is the same as a. I'm going to write that out here. A to the power of 1 is the same as a. And now let's compare the indices that we have here to the index in this index that we have in our solution here. And what do you notice? You notice that that 6 came through adding 3 plus 2 plus 1, which is 6 here. So now let's look at a different example so that we can actually maybe simplify that further without having to write down this long line. So let's say we have 5x y to the power of 3 times 7x squared y to the power of 5. So, because we have here all multiplications, there's a multiplication here, a multiplication here, this is a multiplication, multiplication, multiplication. There's only multiplications involved. So we can again rearrange that. So we have 5 times 7 times x to the power of 2 times y to the power of 3 times y to the power of 5. And now if we want to use what we just learned here about our indices, That's what we're going to do right here. First, let's look at our numbers. 5 times 7 is 35. And then remember that x without anything here is the same as x to the power of 1. We found out here that if we're timesing x to the power of 1 times x to the power of 2, we need to add those indices. So we get x to the power of 3. Same thing here. Y to the power of 3 times y to the power of 5 is y to the power of 3 plus 5, giving us 8. Okay. And I'm going to ask you now to try out a few examples from your book on page 86. Page 86. I would like you to try, please, question 1, H and I, and question 2, A, E, I, K, M, Q, and T. Try those, and I'll see you again for our next chapter video.